Hello everyone, thank you so much for joining our event today, the Botany Behind Christmas, brought to you by the East Anglia branch of the Royal Society of Biology. The Royal Society of Biology is a single unified voice for biology, advising government and influencing policy, advancing education and professional development, supporting our members and engaging and encouraging public interest in the life sciences. The Society represents a diverse membership of individuals, learned societies and other organisations. So we're really happy that you could come along and join us today. My name is Natalie Lamb and I'm chair of the East Anglia branch that's bringing you this event today. And first, a little bit of housekeeping before we start. Please do mute yourself while the speakers are presenting. You shouldn't be able to adjust your muting or your video, but just so you know. We will be recording the event today to add to the RSB YouTube account. So if you don't wish to be recorded, please do leave your camera off and your sound off. After each speaker presents, we will have a little bit of extra time for questions. So please feel free to add these questions either while that presenter is speaking or after the talks, and we will go through them. So now with the housekeeping over, please do feel free to send me a private message or message everyone in the chat if you so wish. And now let's begin. So have you ever thought beyond the magic of Christmas to the plants rooted in our wintertime traditions? This series of online talks from experts around the world will open your eyes to the cytology of the Christmas tree, the conservation of the cranberry, and the maintenance under the mistletoe. We have 3 internationally renowned speakers from 3 different time zones coming to speak with us today about the botany behind Christmas. Now, first up, we have Professor Raja. Raja is an Emeritus Professor with Dalhousie University in Canada, an internationally recognized scientist with over 35 years of experience serving in various universities, national research centers, and at the World Vegetable Center in Taiwan. He has published over 109 peer-reviewed research articles in reputed journals and over 120 abstracts. And he joins us for our talk today entitled Science of Society, A Journey with Christmas Trees. Please give a massive virtual round of applause to our first speaker of today.
Thank you, Natalie. Can you hear me all?
Yep, we can all hear you.
Wonderful. I'm going to share my slide first, actually. Can you all see my slides?
Yep, we can see it.
Wonderful. That's a technologically driven process, so I want to be sure that everything is in there. Wish you all a Merry Christmas, actually, and a happy holidays and a very healthy holidays, actually, to come with the current situations happening around. Let's celebrate Christmas and be happy with what nature has provided us to do. So before I proceed into it, I'd like to thank and acknowledge several of my funding partners that enable me to conduct this particular research, actually. And then my team, there is over close to about 70 of them over different time frames, actually, but no, this is a collective thing that I currently have it. So thanks to all my team members, actually, for enabling me to conduct this particular research. The theme I chose, actually, science to society, is very close to me personally, because I strongly believe if the science has got no linkage, no contribution to society, science itself cannot perish, cannot survive by itself. So I think probably there need to be a contribution or a pipeline or a conduit from science to society. So you'll probably see from this particular journey that I took, and you see that particular linkage that's been created, and that will be very obvious. So the outline for my presentation is I'll be talking something about the history of the Christmas trees, which is, again, to really see where we have come from this Christmas tree as a I would say sort of an example of things that we currently do, and Christmas tree ecosystems in North America, and also talk something about the Christmas tree in the Atlantic region, and try to look at the challenges that the Atlantic and the Christmas tree industry has been facing with or faced with, and some other research dimensions which we took it to solve some other problems and some other outcomes, and what are all the products and technologies that we developed, actually. That will be my outline for my presentation today. Looking at the worshipping trees has been in our culture. Doesn't matter which part of the world we are living from, actually. It's been there traditionally in several cultures, actually. If we look into, for example, in India, the people used to tie mango leaves, banyan leaves, and celebrate occasions with plants, actually. They had all something to do with, no, they didn't know most of the science part of it at that point of time when they started doing it, but the oxygen that it evolves and it filters that air basically coming in through those doors and windows, and as well as basically, now there's also belief that it drives away all the evil spirits and things like that. That's been in vogue basically since our civilization has started, actually. So that's been in there. If we look at the banyan tree, which has been worshipped as a sacred tree, actually, under which the Buddha had his enlightenment, actually. So that is one of the things that has happened. And historically, it has been recognized as one of the things, a great place for meditation, great place for enhancement of our inner health, as well as our physical health as well. And it is also being treated as a worship place, actually. All the trees are being treated as deities, actually, and then worship as gods. That's been in the culture for going on for a long time. And also in Roman time and Egyptian times, the way to treat trees and worship trees being in our culture since very long time. In a pagan culture, it's also been reported to have treating trees for worshiping has been cited in our scriptures, actually. So, and also in Bibles, if you look at some of the verses, actually, it says, I am the true vine, and my Father is a great gardener. She is a tree of life. To those who take hold of her, those who hold her fast will be blessed. And the third one, again, reflects again, the trees being used as worshiping, actually. That person is like a tree planted by streams of water, which yields its fruits in season and whose leaf doesn't wither. Whatever they do prospers. So these are all some of the things that's all in there, actually, constantly been telling us that trees been worshipped since a very long time frame, actually. As far as in the North American context, German settlers who came and settled in Pennsylvania, they started using trees as early as 1737 or 1747 or so. And then the pagan culture, it's become very symbolic in there until it was Americans didn't like that particular thing. But the current Christmas tree practice of using and worshiping Christmas tree has been in vogue since a long time. You can see in the figures, actually, in 1846, Queen Victoria and Prince Albert standing in front of the tree and celebrating Christmas. So this celebrating Christmas and Christmas trees worshiping has been in practice for a long period of time. Coming to the popular Christmas tree species, actually, you can see the world over, basically, different kinds of trees are being used for the purpose of celebrating Christmas, actually. In North America, there are differences. You can see to Norway, if you go to Norway, there is Normandy firs become very popular in there. In the North American situations, or including Canada, actually, the most popular Christmas trees are Douglas fir, followed by Fraser fir, and balsam fir contributes in a very small proportion of the whole distribution of Christmas trees in there. As far as the Nova Scotia is concerned, actually, where I'm from, first Christmas tree export from Nova Scotia was recorded in 1922 by Arthur Manuel from Chester Basin. And that's where the popular Christmas trees of balsam fir is all coming from. As a contrast, if we look into that, US versus Canada, in terms of the production systems, Christmas trees are produced as a plantation crop, like any other apple orchards or pear or almond orchards, actually. But if you come into Nova Scotian situation, it's a very ecologically driven production systems, and we don't do them in terms of a row cultures, actually. And then we plant with other trees and other biodiversity that happens in an ecosystem as well. And a closer view of this one, you can see that the whole acreage is being spread. And these are the soils where nothing else can be grown in there. No, the soils are really bad. And these provides a significant coverage for for the soils, actually, avoiding erosions and things like that. A great contribution, great carbon sequestering system, actually, in that, wherever you see that. And Lunenburg County is a capital for our balsam for Christmas trees of the world. And this is where the major production that occurs basically within Canada. And in comparing the values of the trees, balsam fir is always attracted higher prices because of its very unique properties, especially the aromatic components in there, very unique compared to Fraser fir. Does not have the aromatic component of it, but it's probably has a better needle retention longevity compared to the balsam fir. If you look at the distribution of this Christmas trees, especially the balsam fir, actually, it is mostly in the northern latitudes, as you see here, most of the eastern and central Canada, as well as mid-east US region, as well as northeastern US region, has got an abundant population of naturally distributed balsam firs in there. And balsam fir, although it is preferred as a Christmas trees, Fraser fir dominates the market actually in the North American situation here. And the balsam firs are preferred basically because of its nice aromatic component and the conical shape of the trees and the blue-green coloration that it brings in actually. So it's a very nice, delightful, very tender-looking tree actually when you buy it. So I personally prefer the balsam fir trees anyway. If we look at the overall production worldwide, it is about $1.85 billion, and Canada in general contributes to about $100 million. And Atlantic Canada production is about $72 million for the trees, somewhere around $28 million for the wreaths actually. The overall production is currently challenged with the artificial tree market, which is increasing in trend, which is not a good thing for our Christmas tree industry per se. The challenge that we currently face with, especially the balsam trees in Canada, is now, the trees are cut actually. When it's detached from the root, it becomes a sort of a different entity altogether. Now it's like a chicken head cut off actually. So that's what happens in there. And it is drawn from there and then shaken. And then you can see those, the trend lines that's going there for packaging those Christmas trees. And also been shipped, we take it and drive it about 120, 130 kilometers speed across in the winter, and also shipped in containers, loaded up, piled up, basically. You can see a person standing it up and organizing packing that particular tree, and shipped across the world, actually. The Christmas tree from Canada goes to Bermuda, to Dubai, to Venezuela and Colombia, and all these places down in South America and as well. So they all been stranded, and go to retail shops, actually, you can see this particular site, and it's just been piled up as if it's all dead wood. The trees are still living even after they're harvesting, actually. Okay, so and people do not have that idea in terms of what it is. And after we do all these things, bring it home and set it up, you can see the needle shedding. So the needle shedding has been identified by the producers themselves, one of the critical challenges that's been going on for large numbers of years and decades, actually. And there's been no such research happened in there. And one of the things that changed my perspective into focusing on the Christmas trees research from the other thing that I was doing is the consignment that the farmers sent to British Columbia has been totally rejected because it lost its Christmas trees. It's lost its needles, actually. And then I know that has really contributed, challenged his living and lifestyle and his family and education and so on and so forth. So it is just not about the loss of needle and the research that's needed, but it is about governing that livelihood that he had and maintaining his livelihood. We can also see the needle loss that happens in the wreath as well. So a large quantity of these things been ejected in the past. So generally talking about, as I mentioned, it affects the product quality, reputation of the business, and also it affects the lives and livelihoods, actually. And that was the reason why I was in this particular framework of mine to continue to be contributing to science and bringing that to a society at large in there. When we looked at it actually as a needle loss or a post-harvest needle loss, I call, it's governed by so many factors, including the genetics of the tree. There aren't any varieties in Christmas trees, especially with balsam fir. And it could be the climatic factors, it could be soil related, it could be tree management factors, post-harvest factors, and the time that trees are harvested also make a difference. The pest and diseases, and the consumers, what they do at home, also contribute to the needle obsession in balsam fir. But when you put all these things, I want to develop a problem mapping in terms of what the triggers are coming from, what could be contributing to this particular the challenge of needle loss or needle obsession. And there are several things that I could figure it out, but there are absolutely no literature that's available to support at the time when we started is what is it contributing to it, and where do we go from there? How do we contain this particular problem or reduce the problem? So there was absolutely no information that was there. There's more question mark at the time when we started it rather than answers that is to support our research. So our research, the Christmas Tree Research Center, revolved around 5 major platforms. One is the genetics and tree breeding, molecular biology and omics, tissue culture and somatic embryogenesis, post-harvest physiology, and innovative product and technology development. So I'm going to talk about, I need probably about another 30 days or to talk about all that what we have done, but I'm going to summarize in terms of at least on the post-harvest physiology of things and the technology of things what we have done. So in order to proceed with this, we wanted to really understand the dynamics of needle loss. How does it occur, when it initiates, what kind of a pattern or a trend it is in here. So that's going to give us some kind of a clue. That's why we started with it. As you see from this particular graph, it starts slowly and progressively over a period of time. And that's the point of initiation. And then once it just initiated and then continues gradually and then moves on at a greater speed, actually. And then almost all its needles are lost. There's nothing else to lose in that particular time frame. So this time frame could be different depending on which clone you're looking into, but the trend is almost similar. Our intention is to delay the onset of the needle shed or needle loss. And also what we wanted to do is and suppress that development or further progression of the needle loss. That was our initial goal in terms of what we wanted to do. Looking at it, actually, one of the major challenging things is that the trees are harvested very early to meet the US Thanksgiving. And then the harvest can start as early as in October, actually, and then it's been shipped around the world. So, and we looked at it and say, okay, is that a factor that's going to be contributing to it? So we wanted to do that particular analysis. As you see from the trees are cut very early, that'll have a very low needle retention duration. And as you progress it over a period of time, and you have a better needle retention, or probably the highest needle retention, if you start cutting sometime in late November and December, once cold sets in, actually. And we started relating to all the environmental parameters, actually. And as you can see from here, in this particular graph, the photoperiod has got a significant contribution to make. And if the photoperiod is shorter, you get a better needle retention capacity. As it extends basically to summer, basically, the needle retention capacity is lost, actually, or probably it's very low, basically. So naturally, that has got to do with it. And we tested the different provenances. We got the material from New Brunswick and as well as from Nova Scotia, looked at the range of clones. And then what we see was actually the cold acclimation is very specific to the provenances. With the New Brunswick clones, we don't see much of an advantage when you expose them to cold, whereas the Nova Scotia clones, they get about 16-day advantage basically exposing them to. That's very interesting for us. We also subjected that the smaller seedlings basically to really see what the contrasting is. The cold acclimation is beneficial. As you see from there, the control versus a low temperature exposure is provided a significant advantage for needle retention. And we also observed a specific hormone that seemed to increase many folds, actually, is abscisic acid. The cold induction increases the abscisic acid concentration, whereas if we look at that, it decreases the GA or gibberellic acid concentration in the needles, actually. So that two different factors contributing to the cold acclimation factor. It's a kind of a sort of a membrane protector. When the ABA increases, it becomes sort of a membrane protecting ability that happens in there. We also looked into how the other metabolic events change when you subject them to various months of harvest. You can see, as you see from here, the November, December months record the highest needle retention time. And we can see followed by that is a significant increases over time with raffinose and galactose as pentose sugars. And also we see that major increase in the needle capacitance, which is a reflectance of membrane integrity that happens in there. And as I mentioned, abscisic acid concentrations increase significantly over the month of December and January. Basically, that's one of the reasons why the needle retention is probably much higher. We also looked into water relations. The moment the tree is cut, it is deprived of water up until you bring it home and then install them actually in your little reservoir of water or stand. So we wanted to really look into it. What is the water relations parameter? Is water limitations is reflected in the needle abscission that is happening here. As you see from this particular graph, the needle abscission pattern is increasing actually over a period of time. And you can see average water use efficiency declines over a period of time as well. Also, what we started noticing is a significant amount of a bacterial film that is forming at the cut ends actually, which is depriving the water uptake of the trees. And you can see from here, once that happens, the tension in the xylem conduits increases. You can see that over a period of time, the xylem pressure potential increases actually, or it becomes more negative. And because of that, the relationship suggests actually we have a lower xylem tension. There is every potential for higher needle retention compared to the higher xylem tensions in here as well. So that is again to prove that there is a limitation for water after the trees being cut, and the biofilms that are formed in there is contributing for obstruction of the water flow in there. And all these things can contribute to the membrane changes in it actually. We want to really look into it. We talked about it, the conductance possibilities. And you can see from here, over time, the needle abscission increases, and you can see the capacitance of the particular membranes decline, which is significant information for us to look at. There could be a structural change or probably a components change of the membranes that is occurring on the needles. And we looked into lipidomics work, actually looked into the entire, we scanned and screened and investigated several of those lipids in here. I want to just bring it here. You know, the membranes are the constituents of that are the phospholipid bilayer. And you can see that as the needle abscission, needle loss progresses, you can see the total polar lipid concentrations decline over a period of 11 weeks. And you can see that very specific components, the NGDG and DGDG, and as well as phosphatidylcholine, or the principal component of these membranes, decline over a period of time as well. So certainly there is a membrane is a target basically. And once the membranes are destabilized or disintegrated, and there will be a lot of changes that will be occurring as a cascade of events that might be occurring. So we started investigating what are all the hormonal changes that are occurring in the needles post-harvest. The first one that comes to our figure is your mind is ethylene, actually. Ethylene is generally known as a ripening hormone, which also plays a role in abscission of leaves and flowers and petals and buds and so on and so forth. So we investigated this one at depth. Actually, we found the ones that lose needles early will emit ethylene at very early time frame. But the ones which keeps the needles for a much longer period can release it or evolve ethylene at a later time frame. When we expose them to ethylene, these needle to the plants or the branches, you can see a significant reduction in its needle retention capacity compared to the controls actually. So irrespective of the level of tolerance when it is exposed to ethylene, they all respond in a similar way. So that particular event is caught as eyes actually in terms of saying, okay, if we suppress ethylene synthesis, we'll be able to increase its longevity much higher. So we were successful in achieving that as well. We also investigated the other hormonal fractions actually, which is ABA, which is an abscisic acid. Post-harvest, there is almost like 150-fold increase in ABA concentration and its precursors in it, which is probably a trigger basically in developing abscission zone and contributing for the needle abscission. We also identified cytokinin, especially zeatin riboside, which is a trans form of it actually, which increases nearly 4 folds in terms of a post-harvest, as you see in here. And there are other forms also increase actually during the abscission period. Interestingly, the oxygen concentration in the needles decline basically post-harvest compared to the fresh one, which again tells us that if the oxygen concentration becomes lower in the needles, it becomes much more sensitive to the ethylene to act on it in developing the abscission zone and triggering the needle abscission to follow. So that is one of the great information that we obtain from this particular hormonal study. In addition to it, as we know, the balsam furs are volatile rich in it. It's aromatic compared to the Fraser fir, and the Fraser fir retains the needle much better than the balsam fir. So we want to really look into what is happening there. Is there a variation in volatile terpene compounds? And is there a relationship between volatile terpene compounds and ethylene? Or is there a difference between various specific compounds and the needle abscission? So we discovered about 12 different volatile terpene compounds, and these volatile compounds increase significantly post-harvest before the needle abscission that occurs. Especially 4 of them are of particular interest actually because they occur in significant quantities before needle abscission occurs. That is beta-pinene, beta-terpenine, phenyl acetate, and caffeine, and 3 carins also played a part in that as well. We also looked at the clonal distribution on that. The low NAR clones evolve high beta-pinenes compared to the high NAR clones. We also looked into whether there is a role for ethylene to play in terms of volatile emissions. When we inhibited ethylene, still the volatiles started producing and still we started seeing the needle abscission in that. So we postulated that needle abscission may be triggered by either ethylene-dependent pathway or an ethylene-independent pathway. So it is an alternative system that works in that as well. Putting all these things together, we now have information to saying, okay, what is contributing, what is triggering, what is promoting, and what are all the factors associated with it in terms of the post-harvest needle abscission. So many aspects of it. I've just integrated this one. This was published in peer-reviewed journals, actually. As you see in here, there's a significant contribution from the root detachment that is directly emitting ethylene, as well as synthesizing higher levels of ABA and lower GA and higher amount of CK, contributing to increase in lipids or destabilizing the membrane constituents, triggering the post-harvest needle abscission. Similarly, the decline in water flow also causes dehydration, which triggers the ethylenes and other hormonal factors contributing to the post-harvest needle retention. We also see that directly the membrane damage can occur over a point of time because that can be introduced through a specific enzyme called cellulase, which increases significant amounts post-harvest, contributing to the needle abscission. We also observed several mechanical disturbances that we cause in the packaging, and that also contributes to post-harvest needle abscission as well. And some of the higher amount of soil, nitrogen, zinc, and copper constituents or elements actually can also trigger post-harvest needle retention. So needle volatiles, we talked about it, also contributed to needle retention as well. Very quickly, I'm going to do it. How do you want to put all those things into making the science that we currently know being useful to the producers and consumers actually? So we started investigating how do we package them, our knowledge, into a sort of products actually. So we started looking into product distribution, product development, and distribution. So we developed several formulations, and I'm going to present you some of the things that we have achieved actually. The formulation 24 has increased the needle retention by 136%. And you can see from this particular graph that this particular formulation has delayed the onset of needle abscission, as well as suppressed the progression of needle abscission as well. We have tested it on whole trees, actually, we have got a significant variations amongst the formulations that we have. The formulation AB seemed to be a much more promising one compared to the other formulations that we currently have. And you can see from this particular thing, this is the control with just the water that's been applied after 10 weeks. And you can see the one here with no or almost close to zero needle losses, basically, after 10 weeks, actually. Such lovely aromatic and fresh and green and tender as we see from this particular thing. So this is that led us to several different developmental aspects of the products and technologies. We have developed several somatic embryogenic based Christmas tree seedlings. We have identified several clones, we have bred them, we have extracted the embryos, and then we did that. And also we have developed about 40 different SEM lines, and they were transformed and planted. And we have developed several needle abscission delaying agents, and that's been offered to the industry as well. We also developed an integrated controlled environmental systems that's been offered to the industry as well. There are about 13 disclosures being made to the university, and 3 of the products are licensed for commercialization already. And the first set of SCM seedlings are planted this year, and that's available to the entire Christmas tree industry within Nova Scotia and Atlantic Canada. So that completes my presentation. I would welcome any questions relating to that.
Thank you so much for such an interesting presentation. I'm just going to stop the screen sharing. Thank
you, Natalie.
No, thank you very, very much for that. And we've had some comments and some messages and things come through on the chat. We've got just a couple minutes to take some. So Andrew was saying that in Singapore, that the trees are imported from the US in the most cases, and it's a similar situation in that the preference is for the needle retention or for the fragrance. The two sort of like criteria are for the species of trees that are imported from the US. We have Sven was asking, what effect does bringing the trees inside the house do? What does room temperature do to the Christmas tree in terms of its needle drop?
I think the first thing starts from, if you have an opportunity to go and pick your own trees, I would suggest you go and pick your trees and bring it home without much of this packaging tapes go around, basically, and then bring it home as soon as you can. Give a fresh cut at the base and install them not with a too cold water, with really the water that we can drink. I think we should treat trees as a human species as well, right? We cannot just treat them as dead wood. I think we have to treat them as babies, I would say, and then pour some nice water and replace the water actually before the biofilms develop, and constantly watch for it. I wouldn't suggest putting trees near the kitchen because or near the fruit trays with bananas, and because the bananas can also contribute to evolving a lot of ethylene when it ripens, and any fruits that you have at home would evolve ethylene as it ripens. So which is not a good thing for the trees actually. And cooking also releases a lot of volatiles, which is again, that is not a good thing for your trees. So it's better to keep your trees in your lounge or in your basement if you have a basement, and away from a kitchen. That's what I would suggest, basically using it. There's also we have done that work actually, which I have not presented here, is about the lighting actually. The LED lighting has got a significant role to play in terms of either accelerating senescence in that session or delaying senescence in that session. We have identified some white lights and red lights have got a beneficial thing if you can just get that from that's on your trees rather than the other colors basically. So that's just got a significant benefit as well. So it's how you handle it. Have you bring it home and put them in there. And if you're harvesting it earlier, we're getting it earlier, leave it out there for some time, basically, until you get the first strike of cold, and then probably bring it in at that time and then set it up. I think you will be good to go. That's the first thing. I think you can also use the products that's going to come into the market as soon as our industry is ready to supply. I think the intention is to broadly distribute to the world that the benefit of this research. So that'll be available in a couple of years' time.